Hello everyone, this is DSA Zindabad. Today we are going to solve the third question of Arsh Goyal DSA sheet. The question is remove duplicates from the sorted array. Now let's see what the question says. The question is given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once, right? The relative order of the elements should be kept the same, then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important as well as the size of nums. And at the end, we need to return the key. Now let's look at the example. We are given this array 1, 1, 2, and the answer to this array will be 2. As we can see, now let's discuss this example. This example is 1, 1, 2, right? And out of this, we have two unique elements, right? Two unique elements. So our array will look something like this 1, 2, and we don't need to care about the third index, right? As we can see, our function should return k equal to 2 with the first two elements of nums being 1 and 2 respectively, right? 1 and 2 respectively. It does not matter what you leave beyond the return k. Hence, they are underscores, right? Now let's discuss the example 2 also. We are given this array 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, right? And out of this, we have four unique elements. So the four unique elements ranging from 0 to 4, right? So the array will look something like this 0, 1, 2, 3, 4. And after this, we don't need to care about other elements, right? Now, first of all, let's discuss the approach, how we're going to approach this problem. Now, let's discuss about the approach. First of all, let's take this example, the second example, right? We have 0, 0, 1, 1, 1. And there we have 2, 2, 3, 3, 4, right? So what we need to do, we need to get unique elements, right? Get unique elements. Now, my question is, which data structure store unique elements? Because we need to get unique elements out of this array at the initial start of the array, right? Right there. Okay. So we are going to use set data structure because we need to store unique elements, right? Why we are using set data structure? Because of unique elements, right? So how we are going to solve this problem using set data structure? Now let's discuss this thing. Let's say we have this array, all right? So first of all, what we are going to do, we need to store all the elements in the set. Store all the elements in set data set, right? Let's say this is our set data structure, right? We need to iterate over this array linearly. Let's say our initial pointer is pointing to this now. 0 will be there in our set data structure, right? Now again pointing, since 0 is already there in our set data set, so no, we'll just increment this pointer. Now we'll store 1. Again, 1 is already there. Again, increment our pointer. Again 1. Again, increment our pointer. Now 2. 2 will be stored in our data structure. Now we'll increment until we found a unique element, right? Now we found 3 is the unique element. So we are going to store 3 in our data structure. Again, we found 4. Now our hash set will look something like this, right? And in the question, we are going to return the number of unique elements, right? As there we can see, now our function should return k equal to 5, right? Now what is the value of hash set over there? Its value is 5. But remember guys, we also need to do this thing in place. such that each unique element appears only once, right? There is this thing, remove the duplicates in place. So we need to modify our input array also, right? Let's say after storing all the elements in set data structure, we need to remove elements from set, remove elements, and just manually overwrite our input array. Manually overwrite our input array, right? What I mean to say, let's say there, when we remove 0, this will contain, this will be overwrite by 0. Now, when we remove 1, 1 will be stored there. When we remove 2, 2 will be stored there. When we remove 3, 3 will be stored there. When we remove 4, 4 will be there. Now, we just need to return this, which will be 5. We don't need to care about the other elements as it is mentioned in our code, right? So now let's discuss the time complexity and space complexity for doing this thing. Time complexity would be big of n log n plus big of n, right? This big of n log n is for, like, log n is for inserting all the elements in set, right? And big of n is for traversing over the nums array. And this big of n is also for traversing over the array and removing the elements from our set data structure and overwriting our input array, right? And the space complexity would be big of n because we are using set data structure, right? Now my question is, can we do this thing without using any other data structure, without using set? Because its time complexity is around, like, ultimately big of n log n. Now we need to optimize this approach, right? For doing this, now let's try to think about the optimized approach, right? Let's say we have given an array, right? And we need to remove the duplicates by in place, right? This means we need to use big of n space. This means we are not going to store elements in set data. This means, like, no set, no vector, no array, and no hash map. Basically, what I mean to say, no other data structure, right? We can modify our input array, right? So what comes in our mind? Like, basically, how we can traverse over the array without using any other data structure, right? Let's say we have this array 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. Now we need to traverse over this array, right? And in place, remember, we need to solve this problem here in place, right? Now, when we need to traverse over the array, what comes in our mind? Like, uh, kind of like pointers with the help of which we can build our logic, like how we are going to use pointers, how many pointers we are going to need in this problem, right? How many pointers, right? Now let's discuss how many pointers we are going to need and how we can build our logic using pointer approach. Our main goal is to get unique elements, right? Unique elements. Now, what comes in my mind, like, there will be some pointers according to which we can build our logic, right? Let's say we have two pointers, I and j. Why we need two pointers? We need two pointers because we need to check whether two values are equal or not, right? What I mean to say, let's let me write this thing again. One, let's say our I pointer will be pointing to this and j pointer will be pointing to this. And our ultimate array will look something like this: 0, 1, 2, 3, 4, 2, 2, 3, 3, 4. Now, as we can see, we don't need this 0, right? And we don't need this one. And whenever there is like the value of the pointers are equal, we need to increment, we need to increment our j pointer. Why we are incrementing the j pointer? To find unique value, to find unique value, right? Now we'll increment our j pointer to this. Now, as we can see, I is not equal to j over there, right? Whenever this condition fulfills, then we need to increment our I pointer. Why we need to increment? Because initially our I pointer will be pointing to the initial start of the array, and we are going to store this number because this is the first unique element, right? So we'll increment I pointer to this, and we are sure like we don't need this since this is already present, right? So what we are going to do, we'll change the value of nums of I will be equal to nums of j. Now this value will become 1, right? Now again, whenever these values are equal, we need to increment our j pointer. Now our I pointer is pointing to this one, and our j pointer is pointing to this one, right? And now 1 is equal to 1, so we need to increment our j pointer to this. Now again, I is equal to j. Now again, we need to increment our pointer, right? Again, there is the same value. Again, we need to increment our pointer to j, right? So now, as we can see, I is not equal to j. So again, we are going to store 2 in place of this one because this one is already there at the 1 index, right? So we don't need this one, right? So this one will be replaced by 2, right? Right? Now we'll again increment our I pointer to store the value of 2 over there, right? Now, as we can see, 2 is again equal to 2. So we need to increment our j pointer. Now, again, these both values are equal. We'll again need to increment our j pointer, right? Now, as you can see, 2 is not equal to 3. So what we need to do, first of all, we need to make space for for this element to be present over there, right? So we need to increment our I pointer. So this one will be replaced by 3, 8. Now again, 3 is equal to 3. So we need to increment our j pointer. Now again, 3 is equal to 3. Now again, we need to increment our pointer. Now our jth pointer will be pointing to this 4. And this 4 is the unique element. So we again need to increment our I pointer. Now we'll store 4 over there. Now, as you can see, this array will become this array, right? Ultimately, our array will become 0, 1, 2, 3, 4. And after this, we don't need to think about the other elements, right? Now, at this point of time, we remove all the duplicates, right? At the initial start of the array, right? This is the answer, right? I hope this approach is clear to all of you guys. Now, let's try to code this thing up. Our initial pointer is I, which is pointing to the 0th index. And let's run a loop. And inside this, our j pointer will be pointing to the 1 index, right? J will be less than equal to nums dot size, and we'll increment our pointer. Now, at this point of time, we need to check whether nums of j is not equal to nums of is not equal to nums of I. If this condition holds true, what we need to do? We need to increment our I pointer, and nums of I will become equal to nums of j, right? Now, at the end of this, we are going to return I plus 1. Why we need to return I plus 1? Because our ith pointer will be pointing to the 1 minus index. What do I mean by 1 minus index? Like, because we start our array from 0th index, we need to return the length of the unique elements, right? That's why we are going to return I plus 1. Now, there might be one of the edge cases, which is if our array size is 0. Now, at this point of time, what we need to return? We need to return 0. Return 0 as our answer. Now, let's try to run this code. Nums dot size over there. Now let's try to submit this code. Now this code runs perfectly fine. Now let's discuss this time and space complexity. As we are just iterating over this array, right? So it will require big O of n time. And here we are not using any extra space. So it will be big O of 1. I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, and subscribe, and comment if you have any doubts. Thank you so much.